This is the NECO physics practical question number 3 on electricity. Now in this practical section, I'm going to guide you through it all, and I would like you to stick with me to the end of this video. Now in this practical, we are given a set of apparatus, and they include the resistant box, rheostat, battery, an ammeter, a key, a voltmeter, a touchlight bulb, and some set of connecting wires. And my own prediction goes like this, because I believe that NECO will ask something similar to this, if not almost this. Okay, we are going to connect the circuit as shown in the diagram above with the zero resistance in the resistance bus. Close the key and adjust the rheostat until the current passing through the ammeter is maximum. Read and record the ammeter reading I naught. Also read and record the corresponding voltmeter reading V naught. Do not adjust the rheostat throughout the experiment. Open the key, setting R to 1 ohm. Close the key, read and record the ammeter reading I. Also read and record the corresponding voltmeter reading V. Evaluate the inverse of voltmeter, which is equal to P. Repeat the procedures for 2 ohms, 4 ohms, 6 ohms, and 8 ohms resistance, respectively. In each case, read and record I and the corresponding value of V, and also evaluate P. Tabulate your readings. Plot a graph of I on the vertical axis and P on the horizontal axis, starting both axes from the origin. Determine the slope of the graph and the intercept C on the vertical axis. State 2 precautions taken to ensure accurate results. So this is my own particular prediction concerning this electricity practical. So let's dive into the lab now and let's see the practical. We have the following apparatus for this experiment. These are the rheostats. We have different variants of the rheostat, but for this experiment we'll be using this big one. We have the points where we can connect our wires to the rheostat depending on the pattern of your rheostat. Now, adjusting the slider can increase or reduce the amount of current that enters the circuit. Take note of that. So we have the resistance box. So this is the resistance box. You can see the numbers written. So these numbers indicate the value of resistance that will be introduced into the circuit when we unplug the pin. We have also another variant of resistance box, and this one will be using this for our experiment. If I unplug the 2 ohms there, I have introduced 2 ohms resistance into the circuit. All right. The practical also requested for a touchlight bulb. Now, this touchlight bulb serves as a load in this circuit. And what does a load do? A load introduces a resistance to the circuit. Now, our touchlight bulbs, they have a very high resistance. This is an LED bulb. Now, this is a 1 ohm resistor, which can also serve as a bulb in case you don't have one. It also introduces a resistance to the circuit. So I'm going to be using the 1 ohm resistor in this experiment. I have this large touchlight bulb. This one has a very high resistance, and the battery could hardly power it. As you can see, the light glow is very little. Okay, so we are not going to use that one. So we have our ammeter, we have the key. Now for the ammeter has 2 points of connection, and the 2 points of connection will determine the graduation through which we can read off our values. Okay, both the ammeter and voltmeter has that. As you can see, we have the 2 ampere point of connection and the 5 ampere point of connection. So if you're using the 2 ampere point of connection, you read off your measurements from the top scale, while if you're using the 5 ampere point of connection, you read off from the bottom scale. The same thing goes with the voltmeter. Okay, so that is that. Now, to connect our circuit, so we will first of all connect our battery to the rheostat, going with the diagram for our instruction. We connect the other end of the rheostat to our resistance box. Now from the one end of the resistance box, it moves into our touch light. So I'm going to use this touch light to show you an example of what I said earlier, that it has a very high resistance. So connect the other end of the touch light to the key, and from the key to the ammeter and back to the battery. Now the next thing is to connect our voltmeter. Okay, so I'm going to connect our voltmeter now. One end of the wire from the voltmeter goes to the resistance box, and the other end, see, from the resistance box to the voltmeter, and from the voltmeter back to where the bulb is, the connection, the joint with the bulb. So in that case, we have successfully connected the voltmeter in parallel to the touch light, the touch bulb. Okay, now we close the key. Once we close the key, you can see the voltmeter is reading the potential difference across the LED, across the bulb. Okay, the voltmeter is reading the work done to carry the current pass through the bulb. Now let's see our ammeter to check if our ammeter has any reading. So looking at our ammeter, you can see that this ammeter can barely show any reading. What does that indicate? It indicates that the bulb has a very high resistance. So I try to switch the ammeter, okay, to a smaller ammeter, an ammeter whose maximum reading is 1 ampere, okay, to see if I could detect a current at least in the circuit. So I have switched the ammeter now, and the maximum reading is 1 ampere, like I said. So I will close the switch and see if I could get any reading. All right, so I'm going to close the switch now. I've closed the switch. Now let's see. Now you can see that there's a slight deviation from the reading of the ammeter. Our bulb is working perfectly, and even if we try to adjust the arm of our rheostat, the deflection on the ammeter is still very little. What does that show? It shows that the bulb has a very high resistance. The bulb has a very high resistance. The deflection of the arm of, or the glider of the rheostat, increases or decreases the brightness of the bulb, showing that the current is increasing or reducing. So, but looking at the current indicator, which is the ammeter, we can see that it is little. So we are going to switch the bulb with our 1 ohm resistor. We are going to switch that touchlight bulb, that LED rather, with our 1 ohm resistor now. So I'm going to ditch the LED bulb and switch to the 1 ohm resistor, and then let's watch how the deflection occurs in our ammeter. So I'm going to close the switch now. As you can see, our ammeter has deflected. You can see the value now. It's a good deflection, and you can see the potential difference across the 1 ohm resistor. Now if I increase the glider, you can see that the deflection of the 1 ammeter has passed the reading range. That shows that this ammeter is not suitable for this experiment, because the maximum deflection is way above the graduation. So I have switched back to the original ammeter now that I used previously, and this is the final setup for this experiment. This is my final setup. So like I said, the glider or the arm of this rheostat increases or reduces the current. Closing the switch now, let's see what happens. And with the 2 ohms, with the 1 ohm resistor rather, connected in parallel now with the voltmeter, I replaced this initially with the LED bulb. Now for this practical, I connected the ammeter connection with the 2 ampere maximum reading, okay, and the voltmeter connection is at the 3 volts maximum reading. That means that if I'm reading off both the ammeter and the voltmeter, I'll be reading off from the upper graduation of the two devices, the ammeter and the voltmeter. So adjusting the arm of my rheostat, I'll observe the movement of the ammeter and voltmeter pointers. Okay, and I'm going to take the readings now. So for the ammeter reading here, we have 1.0 ampere. And for the voltmeter reading here, we have 1.2 volts. So this is our I naught and V naught. We take that down. All right. So we will leave the arm of the rheostat at that point, and we are going to increase the value of the resistance through the resistant box now. Now, I will ensure that we have tight connection, because it's one of the precautions to take in this experiment, ensuring tight connection. So if I unplug the one ohm, I've introduced 1 ohm resistance into the circuit, and the arms of our devices decrease. So we are going to take the readings of the ammeter and the voltmeter here. For the ammeter here, we have 0.77 ampere, and for the voltmeter, we have 0.78 volts. So increasing to 2 ohms. Increasing to 2 ohms. What is the value of our ammeter here? Our ammeter here is 0.6 amperes. That's the value of the ammeter reading. And the voltmeter reading there is 0.54. 0.54. All right, so we take that down. Now we have to introduce 4 ohms by just unplugging 2 extra. Now let's take the reading of our ammeter and voltmeter. So with 4 ohms, we have ammeter here is 0.4 ampere, and the voltmeter here is 0.36 volts. 0.36 volts. All right, so the same thing goes when we increase the value of the resistance to 5 ohms, sorry, 6 ohms, by unplugging 1 and 5. We have that the ammeter reading here now is 0.3 amperes, and the voltmeter reading here as well is 0.27 volts. The voltmeter reading is 0.27 volts. So we take those readings down. All right, so we go to when we increase it to 8 ohms. So we will just add extra 2 to the 6. We'll unplug 2 to make it 8 now. So going to 8 ohms, we'll have the ammeter reading to be 0.25 amperes, and the voltmeter reading to be 0.24 volts. Now if you are still watching this video up to this moment, a like or a subscribe to this channel will be appreciated. Now this is the graph plotting. We are plotting the graph of I against P, and you can see our table of values. Our table of values have the units of each column represented, and we have uniform number of decimal placements in there. So the scale here is 2 cm to represent 0.2 units on the vertical axis, and 1 cm to represent 1.0 units on the horizontal axis. And also our axis has its corresponding units also represented. Very important. These are the things you need to take notes during graph plotting. So let's go ahead quickly to plot our points. So now when the value of P is 1.28, the current is 0.77, so we mark out the points. And when P is 1.85, the value of the current is 0.6 ampere. All right, so when P is 2.77 per volt, the value of the current is 0.4 ampere. We mark out the point as well. You can see that on your screen. And when the value of P is 3.7 per volt, the value of the corresponding current is 0.3 ampere. We mark out the points. And lastly, when the value of P is 4.2 per volt, the value of the corresponding current is 0.25 ampere. So we join this graph with a straight line, and that is our slope, finding the point of best fit. And also taking a convenient right angle triangle on the graph, we will find our slope. This slope is a negative slope because it's slanting downwards, not upwards. So slope is change in the vertical axis over change in the horizontal axis. All right, so let's go of evaluating the values we have there. So the value of our slope now is minus 0.16 volt ampere or watts. Okay, so that is that. Now if we check the intercept here is 0.88 ampere on the vertical axis. Okay, so take note of that. So what is the significance of this practical in general? Now the significance of this practical is to determine the power consumption of the load connected in the circuit, the power consumption of both the touchlight bulb and the variable resistance box, the resistance box. Yes, so that is the significance of this practical. Remember, NECO can decide to tweak these questions, but bear in mind that if you can be able to do this and follow these procedures, this electricity practical will be a breeze. Thank you for watching.